I did my undergraduate thesis on safety. I was working for an industrial control company in the summer, through my junior and senior year. They were building pretty classic assembly line automation capabilities. And what I noticed was they were using, obviously, computers to control all this stuff. And the way they tested it was they would just run it. And everybody would like kind of duck and cover their eyes and whatever, because you never knew what was going to happen, right? They thought they coded it right. They thought it would work. Sometimes it didn't work. And the worst part was they had bought this humongous robot. This thing was about 10 feet tall. It could go around in 360 degrees in a millisecond. It was this massive beast that you couldn't get anywhere near, because if you got close to it, it would kill you, right? I mean, it was that powerful and that big. And they were plopping this robot right in the middle of this, manufacturing line they were building. And it just seemed really unsafe to me. I don't know. I'm a little crazy. There's people scurrying around and playing with things and turning stuff on and trying things. And I was afraid somebody was going to die, particularly me, right? I was only an intern, right? How would that be to end your career? And so I actually went to management of this. There's a little company, and I said, hey, I'm looking for a project to do. I'm a computer science student. I noticed you don't really test this stuff. You kind of just run it, and then you kind of see what happens, and sometimes it's kind of ugly. What would you think if I tried to simulate this whole environment? What if I built you an environment that would let you try this stuff out, right, before you actually used it on real equipment? And they said that would be really cool, and so I ended up doing that for my undergraduate thesis, and then carried that forward, got my master's in parallel and distributed systems as well. And then I met who would become the co-founder of my first company. He was doing his PhD work in software testing, particularly high assurance. And of course, we hit it off right away, because that was what I was interested in. He and I, after a couple years of going out into industry and working for the man, we quit our jobs, because we were too dumb to realize that was a really stupid idea when you're like 22 years old. But we just said, we're going to quit our jobs and we're going to build a company to do high assurance. And so my background, unlike a lot of people in Agile, is technical, and it's high assurance. And we built a consulting company that basically went out and helped people doing embedded systems do what we called software safety, right? Making sure that the software performed in a way that the system safety requirements were met. Now, this was really early in the space, right? Give you an example. We had a meeting with a business executive at Ford. This was probably 95-ish or so. And we had some champions in the organization. They'd used some of our techniques. They'd read some of our publications. We did a lot of writing in this area back then. So they geared us up for this meeting. We get into this meeting, and we're talking about safety and the challenges and the issues, whatever, trying to convince this gentleman that we could help Ford. And he stops us partway through the meeting and goes, hold on a second. Hang on. I have just one question for you. Do we have computers in our cars? I was like, uh-oh. We're like, well, yeah. I mean, what we've seen is you have networks in your cars. You have processors at this point. They're all communicating. And he just had a complete blank stare. He was like, well, this is the first time I've heard this. And I was like, well, we're not selling anything today. I can tell you that much. But that was where the industry was at that point. But of course, it's matured a lot in the last 20, 25 years. But these kinds of issues have persisted, all right? About halfway through the journey in that company, I ran that company for 16 years. I sold it in 2007. I read a paper that changed my whole direction of my career. It was by a guy named Kent Beck. Anybody heard of Kent Beck? Anybody? A few people have. Kent Beck, one of the founders of Agile, right? One of the founding fathers of Agile. He invented extreme programming, which is a popular approach to implementing Agile. He invented test-driven development, which is about kind of shifting and using tests to drive development instead of vice versa. And I read a paper on extreme programming. And I almost jumped through the ceiling, because what he was describing in that paper was exactly what I, as a software developer, a former software developer, believed was the right way to build software. It included the customer in the loop, right? So that we didn't get way downstream and find out we were building the wrong thing, all right? It involved testing early and often using white box techniques, which we were absolutely in love with, and all of our analysis was around. So, and it talked about building quality in. Of course, safety and security and reliability are all part of the quality equation. And I said, oh my gosh, this is the future of software development. But I was running this other company, right? Very successful company, software assurance company. We worked in automotive, we worked in medical, we worked in nuclear, we worked in avionics, we worked in mass transportation, we worked in communications. We worked across the board helping people with security and safety. Security, incidentally, is something that this community needs to really look at hard now that everything is internet enabled. We were beating that drum for a long time that, if you're worried about safety, you're worried about somebody who might be malicious deciding to make you unsafe. If they have access through any kind of a internet or network capability, they could end up impacting the safety of your systems. And we talked and wrote about that for years, but that's what we were doing. After I sold my company, I started thinking, so what's next for me? What do I want to do next? I remembered that there was this thing called Agile. So I was like, let me go look. I haven't looked at what's going on out there in the world for a long time. And interestingly enough, I ran into this, right? I ran into these statements about Agile. And I was like, well, I know a lot about assurance. And I think I know something about Agile. I don't see why these statements are being made. And when I dug into it, what I found out was it was a misunderstanding by a lot of people in the community about what Agile was really about. I call them myths, right? And we have a Fundamentals of Agile class. We sell to people that are looking to get into Agile, and we talk about the myths in Agile. And they really all stem from the manifesto. Everybody know the manifesto, right? This is kind of I call it the Declaration of Independence of, the Agile movement, right? Where some people got together and they came up with this document that describes the principles and values of an Agile approach to software development and delivery. And at the top level, this is what the manifesto says, right? It starts off, I didn't put it in here, the preamble says, we as software developers and people helping people build software better have come to value these things: individuals and interactions over process and tools, working product over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan, right? When I read that, I was like, hallelujah, brother. This is the answer. But here's the key, though, this last sentence that people often leave off. And that is, while there is value in the items on the right, we value the items on the left more. Agile does not say anywhere that we don't use tools, that we don't follow process, that we don't document, that we don't live up to the commitments and contracts we've made, or that we don't plan. What Agile says is whenever these are in conflict, we should value the things on the left. So for instance, if your people are telling you that a process you're following is not working, right? Or it's not giving value to the business, or a tool they're being forced to use isn't helpful, should you listen to your people that you pay a lot of money to hire and train and maintain, or do you listen to a process and a tool that can't speak, right? What do? Well, in my experience, you listen to your people. We pay our people a lot more than we pay our process, and our people are a lot smarter than our process, let's face it. And so we should listen to our people. Maybe that means the process needs to be tuned or adjusted. Similarly, there's only really one artifact ultimately that our end customer cares about, our end customer, right? One artifact. They want the code, right? Or in our system, they want the system that houses the code. I'm a software-centric person, right? You can tell. That's what they pay for. All the rest of the stuff has to support the delivery of a product that works, right? Our documentation, the process we follow, the people we hire, all that needs to result in one thing: working software, working systems. And so whenever we have a decision to make, do I build a software system that works, or do I spend my time doing documentation? We should err on building software that works, is reliable, safe, and secure. Right now, in a regulated environment, of course, we've got another customer, right? And it's an auditor, and we've got internal customers that vet what we're doing to make sure the auditor is okay with what we're doing. And that means we're going to have to provide some level of documentation above and beyond what we might otherwise do. There's nothing in Agile that says we don't do that. All this statement says is, in the end, don't forget about the product. If we're compliant but the software fails, guess what? We failed. And we were talking about this last night at dinner, right, in the Boeing situation and some of the other situations. The reality is compliance gets you so far. It probably protects you from negligence. And I've had discussions with people in various industries about this. It protects you somewhat from negligence. You can say, look, I followed industry best practices. I followed what the regulation or the standard says I must do. I did that diligently, I did that rigorously, and I passed. All right? But in the court of public opinion, if somebody dies, you fail. And this is where I personally have always distinguished between compliance and safety, or compliance and security, or compliance and reliability. Whatever the ilities are you're interested in, you have to separate those two. And so you can't just worry about compliance. You have to think about safety in the end, ultimately. And maybe that's what's gotten some organizations in the past in trouble. The third is collaboration over contract negotiation. When does the customer know what they want? When do they know what they want? Well, there's that. Once they see it. At least maybe they know what they want when they see it. Maybe they never know what they want when they see it. But this is a big problem, right? You look at our traditional software development processes, waterfall, V-model, all the stuff we've been doing for a long time. And the problem is that in general, the customer doesn't see the outcome until we get through dev and test. And that's a problem, right? Because if they don't know what they want until they see it, and we don't show it to them for a very long time, guess what? We're going to have a lot of rework to make the customer happy. And that's really expensive at the end of the process. And so that's why Agile has these short increments of building working code. The whole idea is we want to show the customer what we're doing and make it tangible. So it has to be something they can see, touch, feel, whatever, right? So they give us feedback early. Because if they can do that for me in 2 weeks or 3 weeks or 4 weeks, I can tune and adjust, and it's not going to cost me as much as if I get out 6 months, 9 months, a year. All right? So customer collaboration is really important. We have to get the customer in the loop. Doesn't mean we don't care about the contracts, but have to get them in the loop. Last but not least, responding to change over following a plan. Has anybody ever been on a death march project? One where you were just, there's an honest gentleman in the back. One of those that everybody in the room, I'll say halfway through, sitting in a meeting and everybody's thinking the same thing. Should I start polishing up my resume? Because this sucker's going to fail. And we all know it, right? We all know it. The plan we're following isn't working. Now, classic project management will tell you, and I don't want to pick on project managers. I do a lot of project management. You plan the work, you follow the plan, right? That's what you do. But what happens if your people, again, individuals, recognize the plan's not working? What do? Do you double down on the plan? You're headed to the cliff, you accelerate, right? Maybe I can jump it. I'm Evel Knievel. I'm going over the Snake River Canyon, right? Now I'm dating myself. No one's laughing. You all are too young. I'm just going to jump this bad boy. That never works, right? We had the luxury, I guess you could say, to be tangentially involved in a project that will go down in history as one of the most catastrophic enterprise IT projects of all time. Healthcare.gov. You all know what it is? Of course you do. Yes. It was the nationalized healthcare system that was going to or is supporting our national healthcare. We were in that project helping them with some of the DevOps accelerating their kind of delivery process. But watching this huge project struggle, and everybody knew it was in trouble. And we're not talking about 3 months before it was due, or 6 months before it was due, years before it was due. The people on it knew it would never work because of the process and practices that were being followed. All right? Everybody was thinking the same thing. And then it got worse and worse. Somebody should write a book on this project, by the way. There were heart attacks in the office. People had heart attacks from the stress. There was a mandate 6 months out that everybody had to work 7 days a week in the office. You weren't allowed to work from home. So you had to come in on Saturday and Sunday, and you had to clock in and clock out because they wanted to make sure you were there. Magically, a lot of people got sick. Oh, I can't make it. I got the flu. I don't want to infect everybody else, right? There was a guy who passed out, dehydration. How do you get dehydrated in an office building in Reston, Virginia? How's that happen? Not in the desert, right? What happened? We'd been there for 2 days. He hadn't drunk enough water. Passed out, had to be taken to the hospital, dehydrated. And just one last point, we'll get off this one, is everybody knew this was a problem, and we're talking about the people on it, the management of the company doing it, and everybody in the White House, because we saw people from the White House show up every week and sit in meetings with us, listening to how bad this was. And then they all got on CNN and said they didn't know anything about it, which was fascinating if you watch the CNN kind of congressional testimony. Nobody knew anything about this all of a sudden. That's an example of a death march project that we obviously need to change to get where we want to get to. So Agile's misunderstood. A lot of what we hear when I ask why certain things, why don't you think it applies to safety critical systems? Why don't you think it applies to regulation is, well, Agile says you don't document, and we need documentation. Or, well, Agile says you don't follow process, and you have to follow process to get through regulatory compliant. Agile says you don't follow a plan, and you have to plan. They're all myths. Agile doesn't say any of those things. Agile just says we need to do things smartly and do them right. All right? So I decided when I was getting into starting a new company, given my assurance background, given that I thought Agile was the way to do things, I would create a company to help people get to Agile who were trying to do things that were high assurance related, safety, security, reliability related. And that's kind of what we've been doing now at Coveros for about 11 years. One challenge I have is the regulations. Anybody recognize any of these products? Windows 95? Anybody that old other than me? Yeah, a few people. Excellent. Great product compared to the one before it. Not so great today. The iMac, everybody remember the iMac? That ugly looking thing? People loved it. How about this? The first iPhone. There was actually an iPhone before the iPhone. I don't know why they didn't keep the trademark. If Apple wanted it, they could have paid a lot of money for it. It was some, smart phone created, internet-enabled back in the 90s that didn't go anywhere, right? It's too early. My point here is that a lot of the regulations that have been written across the various regulatory, systems that we build were written in an era where the waterfall model and the V model and kind of classic traditional development approaches were the thing. But there's nothing in the regulation that says you have to work like that. But the way it's written kind of almost presupposes it, right? The words they use naturally because of the state of software development was, it reads like that. Now, all these standards have been iteratively updated and upgraded, but the focus has been on, obviously improving the requirements to make sure that things are safe. The terminology and the wording, though, hasn't really changed. It reads old. Sorry, I'm old, but I don't like it, right? Because it gives someone the impression that you have to work in an old school software development process to get through the regulatory process, and it's not true. Now, to be fair, a lot of the regulators and those in industry who govern the standards have started to put out guidance, right, on how to interpret our regulations in an Agile world, because they recognize that a lot of people are trying to move to Agile. And they want to make sure that you can use a framework like Agile to deliver these kinds of systems. So I'm going to walk through a case study. It is for a medical device company. I'm going to give you some insights into what a typical transformation looks like, using them as an example, and weave in some thoughts about Agile and testing and things like that. So we were hired by this company to get their software division to Agile. They had a big business driver. Maybe some of you have these same challenges. Their software releases were taking a long time. They were running on about two-year cycles, which is just mind-boggling to me. But that's where they were at in terms of delivering new releasable capabilities in major releases. They were very concerned about competition. The world was changing radically, and I'm sure you in the automotive industry are seeing this. Automotive is changing radically right now, right? With autonomous vehicles and startups, and it's modernizing, and it's going so much faster than it was, a decade ago, that there's probably some business drivers about how to figure out how to be more productive and make it work. Right? The software team had been promising to figure out how to fix all this for years with no success. By the way, the product is a heart pump. Right? It's used in situations where a patient is in critical care and they're having heart problems, but the patient isn't well enough to accept a pacemaker or some sort of a more long-term solution. And so the heart pump is being used basically to keep them alive until they can be stabilized, hopefully move to a more permanent solution, either a transplant or a pacemaker or something. It was used in triage and in battlefields as well by military. It's used in lots of different scenarios where you just can't afford or you don't have the time to do anything more permanent. All right? The Agile transformation this organization went through took 2 years. So people always ask me, look, I'm using traditional development process. How long does it take to get to Agile? Make sure your execs don't, think it's going to happen in a week or something. I mean, we go into orgs where they think that you're going to get to Agile really fast. The reality is Agile's change, right? It's change, and that's the hardest part. It's not the tools and CI/CD and test-driven development and all the technical stuff. Sure, you got to learn that stuff and make it work, but it's change. People don't like to change, and it takes a lot of effort to get people to change. And that's what you spend most of your time in these on. Now, this one was about 2 years, a little under that. We have a model we follow. It's pretty standard. Kind of figure out where the company is. You build out new process and capabilities that conform to whatever the regulatory requirements are, right? But that documents the process you're going to be using appropriately. And then creating and putting in place any tooling that you don't have. And then you scale it across the rest of the org. So I usually tell people it usually takes 18 months to 2 years. And this is for like a mid-sized company. If it's a Fortune 1000, each of their divisions is probably going to take that amount of time, all right? If you're doing it on a large scale. The other thing is not everybody's going to make it through the journey. People don't like change, right? I like change, right? Every time I give a presentation, even if it's something I've given before, I change it. Because I hate giving the same thing twice. I was like that as a developer. I never, ever wrote the same thing the same way twice in a row. I don't know. But there are people that don't like that. They like exactly what they're doing. Maybe they're close to retirement, right? And they don't want to change anything. Hey, it's good with me. I just want to coast into retirement. We see that a lot in, kind of old school legacy type applications where the same people have been working on something for decades. They don't want to change. Other reasons people might not want to change. Some people are just fine getting away with doing very little, right? Now, I'm not saying your organizations are like that. Nope, I don't want you to think of that one person in the office that seems to slide through. But in my experience, there's usually in most orgs a few people who probably aren't quite carrying the load, and they've been able to kind of get by, right? Agile doesn't let you get by. You're very visible. I always say it's like picking up a rock, right? And all the bugs come scurrying out. because you're very visible in a process where every day you're talking about what you're doing, and you're talking about what you did yesterday and what you're going to do today and what your commitments are as a team. Everybody knows who's not getting things done, and some of those people will leave. They won't like it. They're like, oh, the light is shining on me. I'm out of here. And so we saw this at this company. There were some people that decided this wasn't for them. Some of those people went to a different division. We helped facilitate transfer if they wanted to go somewhere else. Other people left. A few people, management decided, we've tried to coach them. We've tried to get them there. They're resisting. Maybe it's time for them to find a new employer. So some of that happened as well. But it's definitely a minority of the number of people. Most people got into it and really enjoyed it. Investment, in general, it's going to take you $1 million to $2 million to get through this process. If you're getting any external help, you're free to do it yourself. But there is some value in using people that have done it before, obviously. That's usually what we see the range is. People always ask, what does this cost, right, to get through this process? So what we did with this organization, we always start with assessment and figuring out where they're at. Here's where they were at. We have a assessment model we've been using for 11 years. It kind of tracks across 6 different major categories of agility that we measure. And underneath each one of these is 10 to 20 subcategories that we capture as well. And we roll it up into a spider chart that shows you, and the blue is kind of where they scored out. Now these are weighted, so it's not necessarily exactly linear. And the green is kind of where we like to get an organization to. So we try to benchmark up front where you're at, and then we try to create a plan that works to get your organization to where you need to get to. That's the general approach that we take. And it lets us justify what we're recommending. So if someone says, why do you think we should do this? We say, well, let's look at your assessment and where you're at, and you're missing these 4 things. We need to fix that. And so it gives us a way to tie it to kind of the gaps against industry best practices. The last thing, though, is really important. You have to have senior management buy-in if you're going to move to Agile or DevOps. And by the way, I use those terms these days almost interchangeably because everybody I talk to uses them interchangeably, right? Sometimes they say, we want to move to DevOps, and I ask them what they want, and they're like, well, we'd like behavioral-driven development in place. We'd like to use Scrum, and they start throwing out all these Agile things, right? And I'm thinking, well, you're not talking DevOps, you're not talking delivery here, you're talking Agile, right? Or they say, we want to move to Agile, and you say, what do you want? Well, I'm trying to accelerate my delivery process. I want to automate it so I can push it into production. I'm thinking, well, that's DevOps, right? But the reality is today they're the same thing, all right? I always say that DevOps is an extension of Agile principles into operations. Agile is a great thing, but Agile was all about getting everybody on the same page working together. But guess what? They forgot a bunch of people, right? They thought about the developers and the testers and the product owner, business owner, and the business. They forgot about release management and operations and all these people who take software and move it downstream, put it into systems, do work at the system level, and push it out into production. They forgot about those people. DevOps brings them all in, right? So DevOps is really Agile. I call it done right. I have a buddy who always says that DevOps delivers on the promises that Agile made, which I like that, meaning that it is based on those practices, but it includes the entire development process, which is really important. But you have to educate management about this because they often think of these things incorrectly. Someone this morning mentioned, I can't remember which speaker, DevOps does not equal fast, right? Agile does not equal fast, right? If you just focus on speed, guess what you get continuously? Bugs, right? I wrote a blog on it called Continuous Bugs. If all you do is focus on speed, the only thing you do continuously is push bugs toward production. And that doesn't work in this industry, right? And we're talking about people's lives. We're talking about critical systems that have to work. We can't afford to lose quality. And there's nothing in Agile or DevOps that says we have to. In fact, all the studies that are done these days, and you look at the high-performing organizations that are being surveyed in DevOps or Agile, you will see that they have become the masters at balancing speed and quality, getting the quality they need in production at a faster speed. So get to market quicker, but with whatever you need from a quality perspective to meet your objectives from the business side. You have to have both, and if you don't have management that understands that, your transformation is going to suffer. I've seen it many times. Next up with this org, we do what we call a pilot. And that's, define some practices, some processes, make sure we've got all of our processes in place, put some tools in place that help accelerate those processes. Don't do those in reverse order, by the way, and everybody knows that here, right? Tools are great. Tools can help you speed up, and tools can do other things to help you make sure your quality is good, measure your quality, improve your quality, whether it's safety, security, reliability, whatever you care about. But you got to base it on a good, solid process. Make sure you've got your process in place, and then you can accelerate it using automation very effectively. You got to find an appropriate project to apply. This is our model that we created. Feel free to steal it on how we pick a good pilot if you want to try Agile on something, right? It can't be too long or too short. If it's too long, management gets frustrated. They feel like they're not getting a return on the money they're spending. If it's too short, you're not going to really show any value. You're not going to be able to collect metrics and show real gain or return, right? Don't pick something that's huge. It's going to be too hard. But don't pick something that's trivial, because then if you successfully deliver it, everybody will go, yeah, I could have done that. My kid could have done that. That doesn't help, right? You don't want it to be mission critical, right? So you want it to be hopefully something that's important, but not like bet the farm on it. We had a customer once, it was great. Wanted to move to Agile, they came in and said, we got the perfect pilot. We are going to use all new tools. We're going to follow a new process. We're going to use brand new people, because we got to hire for this. And this is a bet the farm for the company on our future. And I said, you are on drugs. You don't pilot something like that. Something new I hear those things, I think risk, right? You don't do that. So just be careful, pick the right pilot to get done what you want to get done, all right? And then you need to spread Agile. And what we did in this organization was, once we got through a pilot and we measured the productivity gains, the quality gains, and what had been done, obviously briefed the leadership on the process and how we did what we did, we worked to transition all that to them, right? Get internal coaches up to speed, get everybody trained so that they could take it and spread it. We'll help where necessary, but our goal is not to drive it when you get to scale. It should be owned by the organization. They have to have bought in and be running the transformation at that point. And then you're going to iterate, right? Because sometimes you're going to identify other things that you want to improve on, and it's a natural iterative process that you're going to typically follow. All right? Here's some case study results, and then I'll talk about some lessons learned and also some tips for moving toward Agile. So we were able to reduce the release process pretty substantially. And incidentally, this is packaged up in the hands of, in this case, FDA for approval. Both the pilot project that we did and subsequent releases were all successfully put through the FDA regulatory process for a safety critical device and approved. All right, so we were able to get them to an Agile process, document that process, train the people and get them to the point where they could do it, and then deliver much faster than they could historically. So from that aspect, it was a success. Also, we were able to put changes through in less than a week. So a question for you all. You all heard, we heard this morning continuous integration. We heard a lot of other kind of DevOps-y terms. How many people in here know the difference between continuous delivery and continuous deployments? Anybody? Because those two terms, when you see CD, it's like an abbreviation, CD, I always ask what it means, because sometimes people call it continuous deployment, sometimes they call it continuous delivery. Someone this morning mentioned Netflix and pushing code through and all your testing being automated, right? When we have a 2-day DevOps class, and I do tutorials at conferences, I always tell people the same thing, all right? The Netflix of the world can do what they do. That's the continuous deployment, where they basically push all change automatically all the way into production, every change. They can do that for a couple of reasons. One is if their software fails, it's okay, right? It's okay. You know, oh, I can't get to my movie, boo-hoo-hoo, for like 3 seconds, right? Because then they just roll it back and they fix it and it's back out there. That's number one. Number two is they have manual testing. They'll tell you they don't have manual testing. Every company has manual testing. Who are their manual testers? The users. Don't forget that, by the way. While we are pushing to automate testing, and all the stats say it's going to continue, right? It's not slowing down because it does increase our productivity while maintaining or improving quality. There are always manual testers involved. The real question is, are you finding the bugs, those of you in this room, or are your customers finding the bugs? Netflix can afford for their customers to find the bugs because nobody dies, right? You all can't do that, ever, ever. You're never going to do continuous deployments. There's always going to be a regulatory step before production, always. And that's okay. That doesn't mean you're not doing Agile or DevOps, because there's other reasons why we don't want to automatically deploy software, even outside of this space. You know, someone mentioned it this morning. Sometimes your customers can't accept change that fast. Right? We work with some large IT organizations who put out software that the people using those software applications are not technical at all. You know, it takes months of training to get them to use the product successfully. Can you imagine if every day when they came in, the software looked different than it did the day before? How they would freak out, right? They would never do that. You could never do that to that customer base. And therefore, they're never going to deliver software every day because their customers can't deal with it. They can't cope with it. So there's a lot of reasons why you're going to do continuous delivery, right? Which is try to automate the process of moving change from development through testing, various types of testing, and ultimately into production with manual effort involved. There will be manual effort in that process because there's certain things we can't effectively completely test automatically, and there's always going to be a regulatory step that we have to go through. Now, I would argue that your goal in Agile or DevOps is to be able to take a change, any change, and automatically put it into production. Why do you still want to be able to do that? Even if you're not going to do that, you're not allowed to do that, why do you still want that to work if you had to use it? Are there situations where maybe you do want to get something in production as fast as possible? Are there? Right? 0-day vulnerabilities, right? There is, heaven forbid, a safety critical issue discovered in the field, right? You know, your system is down or unavailable because of a bug. In those situations, if you read the regulation, you're allowed to push stuff through as fast as you can because the risk and exposure in the field is greater than skipping the regulatory process. And so they all have exceptions for critical bugs in the field that have great exposure when they're discovered. And so you'd like to have your process be able to very rapidly move change into production. So anything 0-day, they call it, right, that's wrong with your code in production, you can find it, fix it, and deploy it out to your customers as fast as your process will let you do. So you still want to be able to do that, all right? Now this roughly shows the process we followed with this company. And we had a cadence. They were 3-week sprints. They're called iterations here. That culminated after 3 sprints in what we call an end game, which is last, gasp, stuff that needs to be finalized before we release. The key here, though, is that's when we finish those activities, not when we start them. All right, you want to move as much of your testing, shifting left, as was mentioned earlier, into your development process as you can. But for some things, you're going to need that final test, that final system, that final hardware to finish that testing. There's certain things you can't finish early. You just can't. because they have to run in a production-like environment, but you'd like to carve off as much of that testing as can be impactful earlier with emulators and simulators and other things, and shrink that end game, that time you need to spend at the end, right? So that's what we try to help this company do, and we've helped other people do it too. All right, so what's some of the lessons learned? As I mentioned earlier, regulations don't restrict software process. All right, if you read them, they smell like waterfall. I'll admit that. That's just it's a legacy of when they were originally written and kind of the words being used. But there's nothing in them that says you have to follow a traditional process. You still need to document it. You still need to verify against it. You still need to trace. You need to do all those things. But an agile process passes regulatory review and compliance. All right? As mentioned, sure, we're going to have to do more documentation. I'm going to talk about documentation here in a minute because we work very hard to reduce the cost associated with documentation for the customers we work with, right? And the key to this, though, is this last point, right? We need to move all of the late life cycle activities, including internal compliance and review and audit, verification, et cetera, into our iterative 2-3 week process and get as much of that reviewed on an ongoing basis as possible. Now, you want to talk about change? For some of the people, this is going to be a major change for how they work, right? They're used to seeing things at the end, all buttoned up, all packaged up, and now you're telling them, hey, I want to see you every other week. I want you in my sprint looking at what's changed and verifying as we go, right? That's going to take culture change. Totally understand that, and it's something you're going to have to work through to make it work. But you have to integrate those in, otherwise you're always going to have that big honking end-of-life cycle set of activities that's going to restrict your ability to push change and push things into production more rapidly. So you have to address that. Second thing is, a lot of people in Agile, they focus on the process aspects of Agile, which are important, right? Am I using Scrum? Am I using XP? Am I using Kanban? How do I do stand-ups? How do I do retros? How do I do the whole set of mechanisms I have to do on a daily basis to implement any kind of methodology I like around Agile, right? That, in my experience, can get you some initial quick hit productivity, but ultimately, your productivity will plateau out unless you figure out how to get developers and testers working together every day, right? Agile is not little mini waterfalls or little mini V models inside of a sprint, right? That's not the way it works. If you're doing that, we call that Scrummerfall, right? Waterfall and Scrum together, you will not be successful delivering working software on a 2 or 3 week cadence. Because throwing things over the wall from design to dev to test in those little time periods just doesn't work. It's not going to scale. Second is, you're going to have to figure out how to automate more and more of your testing in the process. Because with Agile, you're incrementally adding code every sprint, right? As you're adding new capability, the amount of testing necessary increases every sprint. You familiar with the Russian doll? Where you've got a doll and you open it up, there's a little doll, you open it up. I always say Agile is the reverse Russian doll. You start with a little bit of software, then you build a little more, then you build a little more. Every time you add software, you've got to test the new functionality, test the integration of that functionality against the old functionality, and regression test that you didn't break something else in the process. The testing effort grows, and so you can get away originally with just doing manual testing with Agile for some amount of time. But as your code base grows, your ability to get all your testing done becomes impossible. So you have to look at how do I automate some of my testing to make it more successful. And this morning we heard lots of ideas about that, right? Everything from unit testing to your integration/API testing to your regression testing, et cetera, et cetera. When we set up DevOps processes, we always try to shift testing left, automate a lot up front, where you're getting good return really quickly, and then leave some of your more manual efforts for later in the process after you've hopefully vetted and verified the software to at least some level of confidence. One thing we've had great success with is automating part of the document delivery process. One thing Agile is big on that does apply here is there's nothing wrong with documentation. You got to support the documentation you have, but don't write it too early. Meaning if you write docs too early and your only reason to have them is to demonstrate the process that you followed or demonstrate traceability at the end, then why not collect up information as you go and then generate those documents from the information you're collecting, hopefully automatically, so you don't have to maintain that doc as your code changes. We see in organizations, it's a huge productivity sink. And so that often slows down this process. As an example, for this customer, we built them an auto document delivery system, which basically uses Confluence to collect and maintain information online, uses Jira for the requirements, uses Zephyr for test management, some other tools in here I won't get into, like Git for version control, and it keeps those all in sync and tied together so that all you have to do when you're ready is call a Jenkins job or two that we've created, along with a document template that we've created, and it auto-generates the information you're going to give to you first, your internal review team and your internal auditors, and ultimately your regulator. And if you do this, you can maintain all the information incrementally as you go in a way that is provable and time-stamped and verifiable, but you don't have to maintain the actual doc the entire process. And we've seen this greatly accelerate the delivery process for using, in an Agile context. The other thing you need to do is automate your delivery process. So figure out a way to test early, shift left, test often, and constantly be testing and verifying your software as you go. Here's the way we did it for this particular application. I'll tell you that every system you're going to build is going to be different. The tools you're using, the simulators you're using, all the infrastructure is going to depend really on what you have, right? This organization already had some tools. We always reuse tools people already have. There's no sense in trying to do something different, right, unless they just don't work. But we do modernize things if they're using something that's just not functioning. Originally, this is the development and test infrastructure they had. They were using a code repository called CVS. Anybody ever heard of it? Only if you're really old. I heard they were using CVS. I went, oh my God! I haven't seen that since the 80s. Not quite, but that was my first reaction. That's really old technology, right? And it doesn't work very well in a constant changing modern development process. That's what they had. We were like, yeah, that's going to unfortunately have to change, right? And then they had a set of, test devices that they had access to do their testing on the devices, all manual, because there was really no interaction with the device. There was no way to do anything other than that. And so all their testing was manual, and because they were following a traditional process, it was all done manual and at the end. And so their test cycles were very long, because they would, of course, identify problems, and those problems would cycle back, and you'd have to fix them and all that fun stuff. So what we tried to do was fix this, and here's part of what we did. So we replaced CVS with Git, Subversion, Git, whatever you like, GitLab, GitHub. It doesn't really matter as long as you've got some way to merge and branch code properly, which you can't really do with CVS. We set up the development environment was Windows. It was cross-compiled into the real-time operating system that was used on the device. So we figured, well, we don't need to do all of our testing on the device. So we set up a set of Windows slaves. They all had emulators and simulators on them. It turned out their hardware team had emulators and simulators that they used themselves for things they sometimes didn't have. Software team didn't even know they existed. It's like, okay, who'd have thunk it? Once we get these two groups working together, they're like, oh, we have a simulator that does that. Oh, we have an emulator that does that. It's like, well, why aren't we using these in testing? Right? It's ridiculous. So we set up some slaves. We got the emulators and simulators up. We walked through the testing process. We laid it into the delivery process. We talked about what could be started where, what could be done outside of the physical environment, what had to be done inside of the system, and we got the test team working in a more rapid fashion. And we used Nexus as our artifact repository to plop in new versions of code as they got continuously integrated. We used Jenkins to control all this, and this was kind of our continuous integration process with one exception, which was we felt, based on the criticality of this system, and I heard the same thing this morning, that just testing, even at the unit level or the kind of subsystem level, on the Windows slaves, given the flakiness potentially of the emulators and simulators, was not sufficient. And so we had set up a device console pool that was a networked set of consoles that you could access. And we were also running our unit tests and our code analysis, well, our unit tests really, code analysis is all static, and our code coverage also on the device itself as part of the CI process. And then we also use this device, this console pool, to do all the different kinds of testing that we needed to do to meet the regulatory requirements that were necessary, also using the emulators when we could, but recognizing that ultimately it needed to be done kind of in band in the environment itself. We were able to kind of crack the code on getting some communication going. So we used expect. If anybody's familiar with that, it's a way for a device with not a lot of sophistication, no communication protocols to communicate with another device. We found a legacy shell that would run on this environment, and we ported it and got it working so that we could execute tests automatically in the device. And then we used IP locks to determine whether something was in use, not in use, so Jenkins could know if something was available to run a certain kind of test or not and do its thing. So that's kind of how we set stuff up so that we could start testing very early, all during our sprints, doing our unit and API type testing, but then transition into our more late life cycle functional and other types of testing iteratively, but on device as well. That's what we did. So I see we're down to about 5 minutes, so I've got one last slide, and then I'll take some questions. I always like to put a slide called What Your Boss Needs to Know. So this is kind of a wrap-up. If you're interested in Agile and you think maybe you've got the business challenges that I mentioned here, here's some things that you should note. Right? There's really nothing stopping you to moving to Agile if you think Agile can solve your business problems. Now, the first thing I always ask a company when they show up and want to move to Agile is why. Right? Because it's going to take, as you saw, a lot of effort, a lot of change, a lot of work. Don't do that for no reason. Right? You've got to have some reason. Right? I go and I say, why are you moving to Agile? Do you have a quality problem? They go, no, quality's good, safety's good, everything's good. Okay, big competition, like your customers want it faster? They're like, nah, not really. Customers are happy, everything's good. I go, okay, so why Agile? And then you get I heard it's cool, it's new, everybody's doing it. Don't do that. It's not worth it. If it ain't broke, don't fix it, all right? Now, if you have a real business requirement, by all means, move to it. You can do it. There's nothing stopping you from doing it other than inertia. There's nothing wrong. There's nothing in the regulation that's going to stop you. There's nothing in, the Agile principles or whatever that's going to stop you from being successful. But make sure you have a real business need before you do it, all right? Because it is a lot of work and a lot of effort, and some people won't make it. All right, focus first on culture and getting your cross-functional teams in place, right? The cultural aspects are big. You're going to have to work that pretty hard, and focus there first. Once you get your process down, you get it documented, everybody's comfortable with that process, then you start leveraging engineering and automation to accelerate that good process that you now know is appropriate. And then that's where you can really leverage your tools, whether they're development tools, test tools, integration tools, delivery tools, because you know the process is there, right? Don't forget, you want to get your process done first. I always say a fool with a tool is still a fool, right? That just means make sure your process is there, and then tools can really help you. If you're just automating bad tests, well, you're just getting bad results faster, right? Don't fall into that trap. And then balance speed and quality. We can't forget, particularly in this market, making sure that the product we produce has acceptable quality and security and safety, because the success of our businesses rely on it. We are not Netflix. We are not Amazon. We need that level of assurance to be there for sure, and we can't let our customers test. And last but not least, this has been done before. You're not the first one, so you can tell management, hey, it's been done before, all right? So we're not out there on the bleeding edge anymore. It's being used. If there's a business reason to use it, use it, all right? So with that, I thank you all for your time. I think we have a minute or two for questions. If anyone has any questions?
I had a quick question.
Yeah.
For one of your slides, you talked about how you see that one of the big things that kind of kills the Agile process is the heavyweight documentation for everything. And I was just curious how you reconcile the whole trying to do it as a lightweight approach with a lot of the practices or guidances that come through from like 26262 or even like ASPICE for just normal process of design first and having, like, you write your test specifications before you write your test, so you should write out your architecture and your unit design before you even do any of the coding for that. So I'm wondering how, like, what exactly do you mean by a more lightweight documentation process that wouldn't have those same revision issues that
So I'll use design as an example. We've had success, and obviously, industry by industry, there's going to be difference in interpretations of what is doable and possible and what's allowed and not allowed. So I would obviously vet the approach, obviously. But what we've traditionally done is incremental design reviews and analysis. So, in Agile, ideally every sprint, you are working on a new set of requirements. We call them user stories. The first thing you do in that sprint is build a design. So update the old design to incorporate the new capability and create our tests that align with our requirements before we get into implementation and then testing itself. And we do incremental reviews of the design every sprint and have a running history of those incremental reviews to demonstrate and show that the entire system was reviewed incrementally from day one all the way through. And we've had success, getting that approach through regulators. Same with your tests, right? You're really, at any given time, only able to test what you have. And so you make sure those tests trace and tie to your requirements, and you've tested to the level you need to test according to the regulation, each incremental step, and you aggregate that and build it up over time and have an entire history of the testing you've done against each new requirement that's been introduced. That is the way we've typically done it. Does that make sense?
Hi.
Hey, Mr. Question.
Quick question on, well, not quick question.
Uh-oh.
I work for a group that supports a legacy software with safety critical subcomponents.
Yep.
We've had some market problems with velocity.
Uh-huh.
And that was why we adopted Agile in the first place.
Okay. Did it work? No.
We're in the midst of, we've adopted as of 5 or 6 months now.
Okay.
I guess I hear a lot of, we're talking about code coverage.
I didn't mention code coverage, but
I guess when you're in the sort of diagnostic phase, how do you establish quality metrics?
Yep.
We're having a very large problem establishing quality metrics, as well as getting engagement from some of our members to establish even basic velocity metrics. And that's all part of process.
Are you asking your legacy team to go back and create unit tests to cover code for code that never had unit tests, or how are you tackling that problem? Or are you asking how?
I'm asking you.
All right, yeah. So I'll tell you exactly, because we deal with a lot of legacy systems. Now again, depends on the regulation, depends on what's required for legacy, right? But in general, we tell organizations that unless it is required by the regulation, you do not try to go back through your legacy code and write unit tests and cover code. The rationale is, first, it's a huge undertaking, a lot of time and money, right? The second is that code has been running successfully, if it's legacy, probably for a long time and hasn't failed yet. So what would be the business case for doing that? What we advocate is that if you're going to start embracing unit testing and code coverage, that what you start with is obviously any new code you create, you're going to have to write unit tests for and coverage against it, right? 1. 2 is any legacy code you change, you refactor it, you update it, you replatform it, whatever you do that changes it, now all bets are off. It's brand new code, and you need to unit test and code coverage those changes in the legacy system. All right, that's kind of our approach to dealing with legacy. One thing about code coverage, though, and I love code coverage, all right? I've been using code coverage for decades. Be very careful, though, about getting fixated on the metric and not the quality or value of the metric. You don't want to get in the habit of creating tests to cover code, right? That's letting code coverage drive quality. What your process should be is you write the tests you feel satisfy your requirements and the conditions of doneness, right? And then you use code coverage to see, did those tests not cover certain aspects of the code? But then you don't race off and create tests for that. You ask why. Why didn't it cover? Did I forget a condition, a test condition that's critical? So maybe I'm missing some tests. Is this code dead? It's code that you can't get to or that we don't use anymore, right? Figure out what the root cause of not covering the code is, because that's the answer you need to get to. Not, oh, it's covered, so I'm going to create one to cover it. You don't know the value of that test, right? So don't get them switched around. Use coverage as a measurement of the quality of your tests and of your code, and then look at what the root cause of that coverage not being there, and that'll tell you what to do, if that makes sense. All right, thank you.